Welcome back to another episode of Matrix Math here on Code Tech and Tutorials. This time I'm going to show you how to solve linear systems by the substitution method. And if you're not sure what the linear system is, I recommend just going and looking at the last video. It kind of explains how to set them all up and what they look like. So what you need to know about substitution method is it is the human way of solving these problems. Computers don't like this method. Well, we'll get into that a little more, but basically this requires some creative problem solving, and computers aren't exactly good at creative problem solving. So in the next episode, I'll talk about another method where you can kind of program this for a computer, and it's called Gaussian elimination. We're just going to set up a little equation and dive right into it. So we're going to start out with this system of equations. We'll do an x, y, z. So the first equation is x plus 2y, that's a 2 plus z equals 3. And then the second equation is 2x plus 3y minus z equals negative 6. And we have a 3x minus 2y minus 4z. And that one is going to equal negative 2. So what we can do with these system of equations is we can start solving for x, y, and z, and then going through and back substituting in what the results we get. So by doing that, we should be able to come up with some sort of solution. Now it's possible that there's no solution. It's possible that there are infinite solutions. And it's possible that there is a nice clean solution. So we're going to take a look at that. We'll start with the first equation, this one here. So on this equation, we're going to put x off by itself. So we will subtract x from both sides, and we'll end up with a negative x equals, and let's see, we're also going to subtract 3 from both sides. Well, this x cancels out with its negative, so we're going to go right onto that y, and then plus the z, and then negative 3. And then we want to get this negative off of this side, so we're going to just reverse it. So we'll just say, I don't know, I'll scribble it out. Plain old x is going to now equal, well, the negative of all this. This all times negative 1. So what we get there is a negative 2y minus z plus 3. And that's pretty much as far as we can simplify it. X is going to equal that whole chunk of stuff. Okay, very good. So now we want to go to the next equation and attempt to solve for y. But this time, while we're doing this, we can figure out what we learned about x and just substitute this whole little thing in and for that x. So it's going to reset up basically to have, let's see here, 2x. We're done with this one for the moment, so I'm going to put a line. I'm looking at this one now. So we're looking at 2x. But instead of that x, we're going to substitute in the answer we got here. So it's going to be, and we'll go ahead and multiply it through with this 2, just to do it, save a little bit of steps. So what we're looking at here is just, let's see, 2 multiplied by negative 2, y is going to be negative 4y, and then 2 times negative z is just going to be negative 2z, and then we just have this 3, and of course 2 times 3 is 6, so just a positive 6 there. And then we go on with the equation. We have a 3y and another negative, is this negative 2 or negative z? It's negative z. Okay, just making sure. Z's and 2's are confusing. All right. So this 3y, we actually want it to be over here. So we're going to subtract 3y from both sides and add 6 to both sides. So let's go ahead and arithmetic that out how we can here. But also we're going to end up dividing by negative 3 to turn this side into just a plain negative 3. And it's going to look a little confusing. Maybe we don't go ahead and do all the y thing yet. Let's just solve this with the new x in place and put all the like terms together. I think that'll be a little better. here for just a quick solve. So, because this will basically be the first iteration as we go through these. In the second iteration, we'll figure out what y is. So I hope that makes sense, but let's go ahead. Okay, so this positive 3y is going to stay positive 3y then in that case, and subtract z. That's a z. And then I guess I'm going to put a little line through it just to make it clear. There. Now a better z, hopefully. And not a 7 equals -6. So then we have this whole system of equations. We're gonna just combine some things together here. See, we got a y, we got a y. It looks like it's going to be a -y. So we got -y because -4 and +3 is just -1. And then we got a z here and a z here. We got a -2z and a -z. That's going to be a -3z overall. And we've got this 6 here that's just chilling. So we got a +6. And looks like that's all we've got at the moment. And that's going to, of course, equal -6. Okay, and I guess we could put this 6 over to one side just to combine it. So we're going to end up with the same thing, basically, except -12 on one side. And that makes a lot of sense because it saves us a little room. Equals -12. So now we've got that second one. So we got the first x iteration, which is x equals this. We've got the second iteration, the second iteration of the y with that x put in here, and we want to do the same thing with z. So we're looking at this equation, and we'll do one more. Do we have space? I'm not sure. We'll try. I'll see how much I can simplify it down. Let's see, how do we want to do this? I have the third equation, and we're going to substitute in the x once again, and it's going to look like, well, maybe I'll have room right over here to do that real quick. Let me grab this eraser. It's not a big eraser, it's a small eraser. Okay, let's just do it this way then, and maybe we'll have room for the third one over here. So we got 3x. The 3x is going to turn into well, the x is going to turn into this whole setup that we already solved. So it's going to be -6y minus, or which turns into a positive here, because let's see, 3 times, now it's going to be negative still. Okay, 3 times z, that is z, right? Yep, is going to be, of course, or 3 times -z is going to be -3z, and then 3 times 3 is going to be 9, so +9. And then we just keep on with the rest of it. We got a -2y, then we got a -4z, and all that's going to equal -2. So we basically just keep solving this as much as we can. Let's put the y's together. We get -8y, and put the z's together. We get -7z. Wow, that's a confusing one. -7z, and we put the like terms together. It looks like we can just subtract this on the other side, and we will end up with -11. So we got -8y minus 7z equals -11, and that appears to be right for this first iteration. Let me go ahead and copy this, go to our new layer. I'm going to hide my old one, paste that in, and we'll move this over. So now we're on these three equations where we now solve for y. And when we solve for y, we're going to discover a new equation to throw in for y, and we can substitute that back into this first equation, and we can also sub it in for this last equation, and we'll be on our second iteration. So let's go ahead and work on this middle one, and I'll do it up here in this top right area. So let's get -y off by itself by turning it into a positive y and flopping it to the other side of the equal sign here. And the same with this 12. Let's put it on the other side by adding it to both sides. So what we're going to end up with is y equals -3z plus 12. And now we have y all by itself and set up to a whole thing. So we can go, let's see, this is here. And we can take this equation now, and we'll say, okay, well now, since we have an updated z, or an updated y, we can get rid of this y, and by subbing it in. So it's going to be x now equals, let's see, this whole equation. Well, y is this whole equation, so it'll be 2 times all of this. So it's x is going to equal negative 6z, and then let's see, the 2 times 12 is going to be 24 plus 24, and then the rest of here, of course, negative 2, or negative z, I'm sorry, and a positive 3. So that's ultimately going to equal, let's see, let's put the z's together, negative 7z plus, let's see, 24 and 3 is 27, plus 27. So now we simplified our x a little more, all the way down to x equals negative 7z plus 27. Let's see, I guess I didn't necessarily have to substitute into this x yet, so I'm doing this in a little different order than other people might do it. But let's go ahead and go to this third equation and figure out what it is. And so we have a value to put in for the y now. So it's a negative 8 in front of that y, so it's going to be negative 8 times, let's see, yeah. Well, let's just do it. Okay, so it's going to be, this y is going to be this entire thing. So it's going to be negative 8 times negative 3z. And that turns out to be a positive 24z. That's a z. Okay. And then we have negative 8 times this 12. And of course, that is going to be, what? Some large number. I'm having trouble mathing off the top of my head. See, it's at least 80 plus 12. So it's going to be 92, but it's a negative because there's one negative. So it's negative 92. And that's all for that negative 8. And then it was what? Minus 7z equals negative 11. So we can combine these up, the like terms here, and we get, well, let's just make sure this works. We get a 24z and a negative 7z. So we basically subtract 7z off of that, and we end up with a 17z. And we're going to add 92 to this other side. So it's basically going to be 17z equals, let's see, what is 92? Okay, we're at negative 11. We add 92. So basically the number we're going to end up with is the positive of this 92 minus 11. And that is going to be, I can't think, 81. 81. So we ended with 17z equals 81. So that's a pretty good second iteration there. And we can now move on to the third iteration where we solve for z. And actually, we've got it done pretty much already. All we got to do is just z is going to equal 18 divided by 17. And that might be something easy. So this, I'll put a little 2 here for that being the second iteration. Now the third iteration, so I think I have room here. We're going to start with this z, and this is easy. It's z equals 81, and we're going to divide both sides by 17, and now we have z all by itself. And when we come up with this answer, what is it? 17 times 5, I think. Let me pull up a calculator real quick here, and just do a quick 7. Oh wait. Well, 17 times 5 and see if that's 81. No, that's 85. So that's not quite right. Did I math this wrong? I might have mathed this wrong because it's... Okay, let me do this again here. Negative 8 times 3 is 24. Negative 8 times 12. Let me get this 8 times 12. I might have done this wrong. Is 96. So there was a bit of an error there. If you caught that ahead of time, kudos to you. So this is a 96. I just mathed that a little wrong. My bad. So that would basically make this final number over here actually 5 higher. So it's an 85. God, you can't tell that's a 5. So I'm going to do some hyper deleting here and just fix this up real quick so that we don't look like a complete noob. So this being a 96. Yeah, that's a 6. Ah, jeez, what an ugly 6. 96. Deal with it. All right, and this is going to be 85. So now we get 85 divided by 17. And we just can't win here with the overwriting. We're going to have to use the tools of the trade. So what this ends up equaling is a pretty nice even number, because 17 will go into 85 5 times. And so we end up with 5. So z is equal to 5. And now with z equal to just a plain number, we can backfill it into the rest. So I'm going to put an FA here for final answer. And we now know that z is equal to 5. So we can fill this back into the old ones, which we have on iteration 2 here. So I'm going to look at the, let's look at the y. Now let's look at the x. It doesn't matter what order we go. I'll reverse order y it is, since we're on the third one here. So y is equal to negative 3z. So we just basically put in a 5 for the z. So it's going to be minus 15 plus 12, because this will be a 5, right? So negative 3 times 5 is negative 15. And then plus 12. So we're going to come out with the total result here of negative 3. And we can now say in our final answer that y is equal to negative 3. And here we also want to go ahead and do the x. And where's our x right here? Negative 7z. So negative 7 times 5, we all know very well, is 35. So it's going to be negative 35. Look at that. Look at that 3. Negative 35 here in our case, because it's negative 7 times 5. And then we're going to add 27 to that. And we end up with the difference between 35 and 27, which we all know very well is... But what? Because x is supposed to be 4 in our final answer here. So why am I getting 8 and not 4? So let's back up. The first one, I ended up with x equals, let's see, negative 2y. I might have accidentally dropped this negative 2y. So I think this should have been positive, is what we're looking at here, right here, because this, I didn't see this negative, probably negative 2 times the y is going to make this 6 positive. So it's going to be positive 6 right there. And that comes up with a very different answer here. But we'll see if it equals 4 like we intended. So now when we swap in that 5 for z, we get 5 times 5 is 25. Oh, wrong tool. So we get 25 minus 21, and that does equal 4. So now we have x is 4, and that is the right answer for that system of equations. So hopefully we were able to follow that. I feel like I maybe got a little bit messy, but that is essentially how you solve by substitution. And as you can see, we basically kind of methodically go through it and replace and update as we go through. And it's a way for humans to solve these equations. Computers have trouble with it. I feel like there's a way to do it. I bet a computer could do it, because one thing that's unique about this method is these x, y, and z variables, starting from the very beginning when they're in matrix form, they never actually change. So whatever's holding them can kind of be permanently, retroactively updated, but it's still going to be a bit confusing. All right, so be sure to tune in for the next video when we talk about Gaussian elimination. So peace out, guys.